Hello guys, today I'm going to do a quick tutorial on relative speed problems. These kinds of problems show up once in a while on the GMAT, and if you don't know how to solve them, they can be quite a headache, but if you know what you're doing, they're actually pretty simple. And so here's an example. A train leaves New York at 7 a.m., traveling to Boston at 80 miles per hour. Train B leaves Boston at 7:45 a.m., traveling to New York at 70 miles per hour on a parallel track. If the distance between New York and Boston along the tracks is 210 miles, at what time will the two trains pass each other? So the first thing you want to do is put down the information given. And so let me put down that information on my whiteboard here. We have two trains, and there are two ends of a track. And so let's say that right here we have Boston, and on that side we have New York. And so the train that leaves New York leaves at 7 a.m. and the train that leaves Boston leaves at 7:45 a.m. And so let me put down that information as well. 7 a.m. Actually 7 a.m. is the one that leaves New York. This one is 7:45 a.m. Okay, so I just write 7:45 and 7 here. Okay, so once we got that, let me put down the original distance as well. So the original distance between the two cities, between the two trains, is 210 miles. So put that down as well. 210. And this is in miles. I'll just say MI. And then the one that leaves New York is traveling at 80 miles per hour. So I'll put that speed down, and the other speed is 17 miles per hour. So the one leaving New York is traveling at 80 miles per hour. And the one leaving Boston is traveling at 70 miles per hour. So put that down as well. And now that we have this information, there's a very simple strategy for figuring out the answer to this problem. The idea is that we have a formula which is rate equal distance over time, or you can write it as distance d equal rate times time. Well, the only question that remains is what do we plug in here? So when you have two trains or two cars or F1s leaving at different times, your first goal is to get them to have a common start time. So since the train leaving New York leaves at 7 a.m. and travels at 80 miles per hour, at 7:45, it would have traveled 3/4 of an hour. And so at 80 miles per hour, the distance that that train would have traveled will be d equal 80, the rate, times the time in hours, which will be, let's just say, that's 3/4. I'm going to write 0.75. The 3/4 is easier to work with. So 80 times 3/4 is 60 miles. And so at 7:45, this train would have traveled 60 miles, leaving a distance of 150 miles between the two trains. The original distance between Boston and New York, or between the two trains, was 210. So if the first train has covered 150 miles, 60 miles, then there remains 150 miles between the two trains. So now that we have this information, we're ready to plug into our formula one more time. So actually, you might have to use this distance equal rate times time formula more than once. So in this particular case, we need to use it twice. So the first time we use it to calculate the distance traveled by the first train from 7 a.m. to 7:45. Now the two trains are traveling toward each other at 7:45 a.m. with a common distance of 150 between them. Now, the distance that you plug into this formula, if you have two trains starting at the same time, is the common distance between them. So that's 150. And then the rate that you plug into the formula is the combined rate, or the relative speed. So the relative speed, if two trains are traveling toward each other, you add up the speeds of each train. So 70 plus 80 will give us 150 miles per hour total. So they are covering this distance at a relative speed of 150 miles per hour. So that's what we plug in for the rate, 150. And then the time actually is what we're looking for. So based on this, we can say that it would take 1 hour for the two trains to cover the distance of 150 miles. So 1 hour is the time. And so if the two trains at 7:45 a.m. are traveling at a relative speed of combined speed of 150 miles per hour toward each other, they would cover that distance of 150 miles in 1 hour. And so in 1 hour, 1 hour after 7:45, they would be somewhere here. One of the trains would have traveled 80 miles, the other would have traveled 70 miles, but we don't really care about that. The important thing is that they will meet or pass each other at 8:45, exactly 1 hour after 7:45 a.m. So that's the answer to our question. At what time do the two trains pass each other? They will pass each other at 7:45 a.m. And the problem solving process that I followed here is summarized here. So essentially you have this rate formula, rate equal distance over time, and there's a two-step process involved. The first step involves getting the two trains to start at the same time. And what I did here was I figured out where the first train will be at 7:45 a.m. by multiplying the rate by the time traveled from 7 a.m. to 7:45 a.m. So I figured out that the first train would have traveled 60 miles, meaning that if they're starting at a common time of 7:45 a.m., they would have 150 miles between them if the first train has traveled 60 miles. So that's the first step. The second step is to decide whether you're going to add or subtract the train's individual rates to get the relative speed that you're going to plug into the formula the second time. So this second time, I decided that since the trains are moving toward each other, I will add up their speeds to get the relative speed. So the rule here is that if the trains are coming toward each other or going away from each other, you add their speeds. But if one train is catching up to the other, then you subtract the speeds to get the relative speed. So essentially, here we had to add the speeds up and came up with a relative speed of 150 miles per hour. And since the distance is 150 miles, it will take only 1 hour to cover that distance. And so our final answer is that the trains will meet 1 hour after 7:45 a.m. So that's the process of solving relative speed problems. And so if you have any questions about this process, you have my email. It's bbaah123@gmail.com. I've put this on the site, and so you can contact me if you have specific questions by email, and I'll be happy to respond to your question. But feel free to also contact me about any general questions about a GMAT that you may have. All right, I hope you learned something and enjoyed this video, and good luck preparing for the exam.